Welcome to The Explainer. We're about to dive into a really fascinating and honestly a pretty challenging new theory about cancer. It's a theory that basically says everything we've been told for the last half century about where cancer comes from might be wrong.
So, you've probably heard the story a million times, right? Cancer is just bad luck. It's this genetic lottery where random mutations hit your cells and they just start growing out of control. But what if that's not the whole picture? What if the real story, the root cause, starts somewhere totally different? I'm talking not in our DNA, but in the tiny little power plants that fuel every single one of our cells. All right, so let's get right into it. To really get our heads around this new idea, we need to look at the two big theories that are kind of battling it out right now. You've got the one we all know, and then there's this other one that, well, it pretty much flips the script on everything. Okay, so in one corner, you've got the heavyweight champion, the idea that's been dominant for decades, the somatic mutation theory. This is the one that says cancer is fundamentally a genetic disease. It's all about a buildup of random mistakes, mutations, in a cell's DNA that basically tells it to grow without stopping. But in the other corner, you have the challenger, the metabolic theory. And this theory says, hold on a second, the problem doesn't start with the genes, it starts with a broken engine, with damaged energy production inside the cell. Now, this is where it gets really interesting. If the genetic theory is the whole story, then a few things just don't add up. First, check this out. Scientists did these wild experiments where they took the nucleus, the part with all the bad mutated DNA, from a cancer cell and put it into a healthy cell. So what happened? Did it create a tumor? No, nothing. Second, these so-called driver mutations, the specific genetic mistakes that are supposed to cause cancer, well, they're found all the time in perfectly normal, healthy tissue. And get this, for a third point, some really aggressive cancers don't have any significant mutations at all. All of this kind of points to the same thing, doesn't it? Maybe, just maybe, the mutations aren't the cause, they're the effect.
So, if the genes aren't the main culprit, then what is? Well, to get to the bottom of the metabolic theory, we've got to rewind the clock, way back, almost 100 years, and take a look at the tiny little engines that power every single one of our cells. Believe it or not, this whole idea started way back in the 1920s. There was this Nobel Prize winner, a guy named Otto Warburg, and he noticed something odd, something really strange about the way cancer cells get their energy, how they eat. It was this huge clue, but for some reason, it was mostly ignored for decades. Now, though, it's making a massive comeback and is right at the center of this new wave of cancer research.
Okay, so think about your cells. Inside every single healthy cell, you've got these tiny little power plants called mitochondria. They're like these incredibly efficient engines. They take the food you eat, they mix it with the oxygen you breathe, and boom, they crank out tons and tons of clean, efficient energy. It's a beautiful process called respiration. But here's what Warburg found. When those little mitochondrial engines get damaged, the cancer cells don't just give up and die. No way. They switch to this ancient, primitive backup generator. It's a system called fermentation. It's super inefficient, it doesn't need oxygen, and it's basically the same energy system that bacteria were using to get by billions of years ago. It's like a survival mode. So for a long time, pretty much everyone, Warburg included, thought this fermentation process ran on just one thing, sugar, glucose. That was the story. But recent research has uncovered a massive plot twist. It turns out there's a second hidden fuel that's been lurking in the shadows, and finding it has completely changed the game. So how did they find it? Well, scientists like Professor Thomas Seyfried came up with this really simple but totally brilliant experiment. Here's what they did. They took some cancer cells in a dish and just starved them, took away all their food, and they watched as the cells started to die off. Then, one by one, they started adding back different potential fuels just to see what would happen. So they added sugar back. And yeah, it kept the cells hanging on for a little while. But then they added something else, and the cells went ballistic. They just exploded with growth. And what was that second fuel? It turns out cancer cells are absolutely ravenous for the most common amino acid in our blood, glutamine. And just as Professor Seyfried said, this was it. This was the missing piece of Warburg's puzzle. See, cancer isn't just a sugar feeder, it's a dual-fuel monster. It depends on both glucose and glutamine to grow and thrive. And with that discovery, a theory that was almost 100 years old was finally complete. Okay, so let's pause and think about what this means. If cancer is a disease of broken metabolism, if it's locked into using these two specific fuels, well, that points to a whole new way of treating it, right? Instead of just poisoning everything and hoping the cancer dies first, what if you could just starve it?
And this right here, this is the cancer cell's Achilles heel. Think about it. Our healthy cells are amazing. They're what we call metabolically flexible. They can run on glucose, glutamine, fatty acids, and even this super efficient fuel called ketones. They can switch fuels like a hybrid car. But cancer cells, with their broken down mitochondria, they're stuck. They are metabolically inflexible. They're like an old gas guzzler that can only run on glucose and glutamine, that's it. So this lays out a really clear strategy, right? It's called metabolic therapy. Step 1, you cut off the glucose supply. You do this with things like a ketogenic diet or fasting. Step 2, you use specific drugs to block the cancer cell's access to glutamine. So what happens? Well, your healthy cells just switch over to running on ketones for energy, no problem. But the cancer cells, they can't use ketones. So the result is incredible. You're nourishing your healthy cells while you selectively starve the tumor. It's a complete paradigm shift.
Okay, now let's look at a brand new strategy that's emerging from all this. There's this fascinating new study that really shows just how powerful this whole idea of putting metabolic stress on cancer can be. And it uses a tool you would never expect. So in this study, researchers were looking at these really aggressive cancers that have a specific mutation called KRAS. You can think of KRAS as basically a growth switch that's stuck in the on position. And what they tested was a combination therapy, a fasting mimicking diet to lower glucose, paired with high-dose vitamin C. They tried this out in lab dishes and in mice. And the results, they were absolutely staggering. Look at this chart. The fasting diet by itself, yeah, it had some effect. Vitamin C by itself, same thing, a moderate effect. But when they put the two together, boom, a near total wipeout of the cancer cells. That's not just addition, that's synergy. The two working together were way more powerful than either one alone. But wait, because here's the crazy part, the real twist in the story. We all think of vitamin C as an antioxidant, right? Something that protects our cells from damage. Well, in this situation, it did the exact opposite. Inside that weakened, metabolically stressed cancer cell, vitamin C flipped its role and became a pro-oxidant, unleashing a massive storm of destructive molecules. So how does that even work? Well, it's a perfect 1-2 punch. First, the fasting diet weakens the cancer cell. It starves it and makes it vulnerable. Then, the high-dose vitamin C comes in like a Trojan horse. It gets inside the cell and unleashes a ton of free iron that's normally kept locked up and safe. This free iron then just creates chaos inside the cell, causing massive internal damage. Your healthy cells can handle this no problem, but for the already weakened cancer cell, it's lights.
So when you put all this together, it really changes how you think about cancer, doesn't it? It starts to look less like a random genetic lottery and more like a condition that's deeply, deeply connected to the way our bodies make and use energy. It suggests that all the things that can damage our mitochondria, a poor diet, not enough exercise, chronic stress, all those things might be playing a much bigger role than we ever thought. And that leaves us with a huge and maybe even empowering question to think about. If cancer really is a metabolic disease, what does that mean for how we live our lives every single day?